Imagine completing a critical pressure vessel weld, and then failing inspection because your welding procedure wasn't properly qualified. That's not just a rejection, that's rework, delay, cost, and sometimes loss of reputation. In today's video, we are going deep into one of the most important documents in welding quality control, the Welding Procedure Qualification Record, or PQR. If you are a welding engineer, QA/QC inspector, fabrication supervisor, or preparing for CSWIP, ASME Section IX, or AWS exams, this video is for you. Let's understand how to develop a PQR step by step, the correct way. Before we jump into steps, let's understand the foundation. A WPQR, Welding Procedure Qualification Record, is an official documented record of welding parameters and test results obtained during the qualification of a welding procedure. It proves that your welding procedure can produce sound welds that meet mechanical and metallurgical requirements as per code. Important. WPQR equals actual test record. WPS equals working instruction derived from WPQR. Without WPQR, your WPS has no technical validity. Now let's go step by step in the correct professional sequence. This is critical. You must identify material specification, e.g., SA 516GR.70, P number, group number, thickness codes like ASME Section IX classify materials by P number. Why? To reduce unnecessary qualifications. If you qualify P number 1 material, you may cover multiple carbon steels under that group. Thickness qualification range is also important. Example, if you test on 20 mm thickness, it qualifies for a specific thickness range, not unlimited. Select the welding process first, decide the process, which processes you will use. General welding processes are SMAWGT, AWGM, AWFC, AWSO, or combination process. Why is this important? Because the welding process is an essential variable under ASME Section IX. If you change the process, you must requalify. Example, if you qualified with GTAW SMAW combination, you cannot directly use only FCAW without requalification. Step 3. Define welding type. Next, decide whether welding will be manual, semi-automatic, automatic. Automation affects heat input consistency and weld quality. In pressure vessels or refinery work, controlled welding is extremely important. Record this clearly in the qualification. Step 4. Select filler material. Now choose the filler metal. Record, AWS classification. F number, electrode diameter. Brand if required. For example, E701 F number 4. Changing F number may require requalification. Make sure filler metal matches. Base material strength. Service temperature. PWHT requirement. Set welding position. Positions include flat, horizontal, vertical, overhead position. Effects. Welder skill. Mechanical properties. Defect probability. Establish preheat or interpass temperature. Preheat prevents hydrogen cracking. Rapid cooling. Hard microstructures. You must record minimum preheat temperature, maximum interpass temperature. These are essential variables in many cases. Never guess preheat. Calculate based on carbon equivalent if required. Decide on PWHT, post-weld heat treatment, if required by code or client. Record. Temperature holding time. Heating rate. Cooling rate. PWHT effects. Residual stresses. Toughness, hardness. Changing PWHT conditions may invalidate qualification. Design the joint configuration. This includes groove type, V, double V, U, root opening. Root face. Backing, yes, no, bevel angle. Joint design affects penetration, weld, metal volume. Heat input. Always document with a sketch in PQR. Fix electrical parameters. Record actual values, current, AC/DC, polarity, DCEP, DCEN, voltage, amperage range. Travel speed. Heat input directly affects weld properties. Heat input formula. Heat input equals voltage multiply current multiply 60 divided by travel speed multiply 1000. Precise control is critical during qualification. Shielding gas record. Gas type, argon, CO2, mix, percentage composition. Flow rate. Gas composition changes can be essential variables. Example, changing from 100% CO2 to a pure CO2 mixture may require requalification. Record number of passes. Multi-pass welding affects heat input, affects microstructure, affects impact properties. All passes must be recorded in PQR. Welding of test coupon. Now comes the most important stage. You prepare a test coupon, plate or pipe, under controlled conditions, using selected parameters. Important: the welder must follow the intended procedure exactly. No parameter adjustment outside planned range. Testing phase. After welding, testing begins. Non-destructive testing, NDT, visual testing, VT, radiography, RT, or ultrasonic, OT, magnetic particle, MT, dye penetrant, PT. This ensures weld soundness. Destructive testing depending on code. Tensile test, bend test, impact test, hardness test, macro examination. Each test has acceptance criteria defined in the code. Example: tensile strength must meet minimum specified tensile of base material. Evaluate results. Now compare actual test results vs code acceptance criteria. If all pass, qualification successful. If fail, requalification required. Never manipulate data. Documentation or finalization. Now prepare official WPQR document including all welding variables, test results, NDT reports, lab reports, joint sketch, welder ID, date, code reference. Store in PQR database. CAR documentation system. This document becomes the foundation of your WPS. Your WPQR is not just paperwork. It protects your company, your project, your professional credibility. A properly developed WPQR saves lakhs of rupees in rework. If you found this detailed explanation helpful, give this video a thumbs up. Ka chinha. Subscribe to WeldFab World for more deep technical welding and fabrication knowledge. Comment below, which code do you work with, ASME, AWS, or ISO? And if you want a separate detailed video on essential vs non-essential variables under ASME Section IX, let me know. Until next time, keep welding safe, keep welding smart.